Hey, how's it going, guys? Electron, man. Well, I got me a new meter. I got me a VTVM meter, and picked her up. And of course, they said it worked, and unfortunately, it doesn't. But it's in really nice condition. And fortunately, I did get an owner's manual and a schematic with it, so I think we can bring her back. I hope so. Basically, your schematic. Have to kind of take a look at that. But right now, basically, what I got is I do get an indicator light that comes on, but I'm getting no meter movement whatsoever. Have to get in here and start doing a little diagnosis. It does have one tube, and we'll check the tube and then go doing a little troubleshooting and see what we got going on here and bring this thing back to life. Okay, guys, well, I got her apart here, as you can see. Thank goodness this older equipment, they really make it a lot more easy to service than this newer stuff. But here we got our meter out here, and went ahead and pulled the tube here. What is this? This is a 1287. That's a pretty common tube. We'll go ahead and test that tube. I was sniffing around here already, and did find that it has a blown fuse, a 1 amp blown fuse. So we'll go ahead and test the tube and go ahead and put a 1 amp fuse back in it. It's one of them pole fuses. Put one of them in there, and we'll see what we get there. Hopefully that's all it is a bad pole fuse, and we'll be back up and going. Let me go ahead and get the old. As you can tell, I have a lot of BK equipment. Let me go ahead and plug this in here. 1287. If you haven't used a tube tester before, this is a little chart you have. So get over here, 1287. So it's socket 12. No, wait a second. It's heater 12. Heater 12. I use 48. I use 48. I say 4840. 1287. 1240 10. Two. And socket 2. Okay. Tube looks good just looking at it visually. GE tube. Let's go ahead. Get it locked in there. Heat up for a little bit, and let's see what we got. Oh yeah, real good too. So somebody might replace that. We're 86%. Well, that's awesome. No problem with the tube. So, tube test tube. Oops. Go ahead and put this up, and let me get in there and put that new resistor or fuse in there. It's one of them damn pole fuses. I don't know if I got one or not. Hopefully I do. If not, I'll see what I do by coming up with one. Okay, well guys, I'm back like magic, and now I have a pole fuse. What I mean by a pole fuse is basically it has leads that are connected to a fuse body. You can make these, but I wanted to kind of look factory correct, so I did that. The old one's right here, and it was definitely bad, so we're gonna go ahead and solder this guy back in here, and then see where we're at. Which, by the way, I had to go to the electronics store. When I did, I went ahead and picked up all the electrolytic caps for the unit here. I figured while we're in here this deep, the old caps are old and tired. Let's just go ahead and put some fresh ones in there. And I think I got about $10 with the fuse in this, so might as well just go ahead and rebuild it while we're at it and get rid of them old caps. These things are 50, 60 years old. Or I don't know, it's probably 50 years old easy. Anyway, so we'll go ahead and we'll do a whole cap replacement. Let me go and get the fuse in here and start doing some cap replacement, and I'll be back. How's it going, guys? Well, still working on this silly thing. Basically, I have now replaced pretty much all the caps, and I've tested them all. There's two in here still that are the original ones, and they test good, and they're really a pain to get to, so I'm debating on whether I want to mess that up. But anyway, I found actually only found two bad caps, one open cap, and one that was way out of tolerance, and that blown fuse. So now I'm hoping to be able to go ahead and fire this baby back up and see if we've got some action on that. If you remember before, I showed you, I believe I did, I have to go back and look at my video, that when I started with this, I was getting basically no reaction at all from the meter or anything. So let me bring his camera around here and let's see here. I'll bring her up with a Variac. It's 4.3 watts, so we're not drawing anything unusual on current, which we shouldn't be. We weren't before either. Let me see here. Let me go ahead and let's turn her on, see what she does now. Let it warm up. Yeah, it is on. The light's kind of dim to see. Let me vote some my feet right now. Okay, let's see if we get anything. Well, we got a light, but do we got any meter action? Hey, bearing it that way. That's right or not? Cool. Okay. Well, we do have some meter action going on. I guess step 2 is let's go ahead and get the probes hooked back up on this and see if we actually have got it fixed before I go putting it back together. Okay, let's see what we got going on now. Well, we know we've improved it. At least we have meter action now. Let me go ahead and turn it on. Let's just go ahead and go for resistance right now. Ohms, I mean. Same thing, actually. Well, we should be getting some reaction there, shouldn't we? Okay. Yeah, on these guys, really what you want to do is kind of start it. Get to go kind of middle, and then from there we'll center it. And then what I need to do here is just take my probe and my ground and hook them together. And it should zero out. Well, that's weird. Okay, well, darn. And I thought that was going to be it, and it's going to be easy. Oh boy. Okay, well, let me go back and do some more troubleshooting here. We're going to have to start tracing the schematic down and find out why we're not getting any signal to the probes for sure. Okay, let me get to work on it. Man, I'll tell you what, guys, I've been tracing, and this ain't making no sense to me. Maybe you guys can help me out here. This is just not making any sense at all to me. What is going on with this silly critter? Okay. I'm not getting signal to the voltmeter, obviously. For whatever reason, it's not receiving signal. And so anyway, I got the tracing back, and right now where I'm at, the center lug obviously is your center tap for your signal. I just got it on continuity tester right now. I'm just tracing to make sure I've opened or closed connections. And if I put my dial here and follow this around, if you see here, you've got this red and yellow wire that comes out of here, and that goes into the selector switch. When I come over here, So I'm getting signal all the way into here, and if I trace it across to here, oh wait, I trace it across to here. I lost my thought train here. I'm getting the signal all the way into the tube, which I should be getting some deflection or something on that meter when I do a short. If I got that, okay, and then if I take this guy right here, which is your probe, and I take the center deal there, and I plug it in there, which is what goes into that. Then go over to the probe. I've got signal from the probe. And now here's where it gets bizarre. Now then, let me go ahead and connect it back up to the radio. I mean to the meter, to the VTVM meter. Tighten that up. Now then, we just check this wire here, the probe to the connector. So we'll go back where we were. We know it comes in right here on that red and yellow. Believe it or not, guys, right here comes in. This loops around here, comes in red and yellow. This is where the signal actually comes from the probe and goes into the multi-mode selector switch for the deal. And then I go over to the probe. I'm not getting any continuity there, and I should be. Why am I not getting? How can that be? I checked the probe, I checked that, I checked that. It's just a flat connector. This is making no sense at all. But I can unscrew it off of here. And I got continuity there. I got continuity there. This is making no sense. Oh man, and that's getting good contactor. I can tell that. Well, guys, let me go do some more fishing here. Strange. Anyway, there's a new capacitor that was bad that I put in there. It was a, I remember what it was. I think it was a 10, 600 volts, something like that, and a new pole, 1 amp pole fuse, and where was that leaky one at? It was down in here, and it was a, it was unusual. It was a 1600 10 volt. Anyway, let me, this has got me really scratching my head. Doesn't make sense. Okay, well, I'll be back, guys. Well, guys, I believe I finally, well, we'll find out here in a minute. I'll come back and test it, but I believe I found the problem. What a weird one. I'm not familiar with these connectors like this, and in fact, you know, it's old equipment like this. The pros I've had, I've always just used. Well, you know, I was showing you I was getting continuity, and luckily, one time when I was testing it, I pushed down on this a little bit, and when I pushed down on it, it lost connectivity. It's like, why would? So when I tighten this down to the connection on the meter, it pushes down and it loses connectivity, which makes no sense. It should get better connectivity. So anyway, I'm off camera. Sorry, I wish I'd had it on. There's one little lock screw here. You take this lock screw out, and this wire comes out, and this is just a plastic piece here with a center. Well, the way these connectors work is, which took me a while to figure out, but basically the center core of the coax that's on this cable here is stripped, and then it's kind of like an SO239 except for it's flush there. So I just took my solder remover, removed the solder out of there, and there's actually a hole down in the center there, and cleaned out the solder, and then cut that coax back, stripped it back, got it sticking through like 1/4 of an inch, soldered it back to make a new button, and I now have it to where if I push on it, it doesn't lose connectivity. Actually, when I took it apart, it just came apart in 2 pieces. So, which is weird. You would think that pushing against it would make it have continuity. The opposite happened. It actually, when you pushed against it, it would lose a little bit of connectivity it had. And the only way it was getting it, I guess, was static, because it had completely broke that solder joint. I don't know if somebody had twisted this wire real hard in here or what, but yeah, it was no longer soldered to that center button. And that's why I was not getting any signal through at the end of the day. So anyway, let me go ahead and get this turned around and powered up again. And God, I hope we got her going now. I think we do. Okay, let's power back up again. Want to let her warm up for a second. Okay, I'm getting meter deflection. Go ahead and go to ohms. I should go about middle scale. Okay, that's right. Kind of zero it out a little bit for middle scale here. And then we should, fingers crossed, now we should be able to take, and this, when I ground this probe, it should go to infinite. Or actually, it should go to zero. No, it would go to zero. But it did something. Yeah. That was it. Wow, that is crazy. Okay, so now what I do is I'll zero out the ohms. No, you zero it out here. Okay, so you zero that out. Disconnect that. And then ohms should be zeroed out over here to infinite. So now it should be reading ohms. Okay, here's a 50 ohm resistor. Which, let's see, that means it should be right around there, somewhere around between 40 and 100. Should be right there if it's working. Drum roll, guys. Drum roll. Wow, right on the money. Right on the money. It's actually showing, what, about 48 ohms? This is active too, so probably an even more accurate measurement than I will get from this old digital voltmeter, but about 48 ohms. Ah, awesome. Awesome. Actually, I need to. Test her again there. Duh, might have I used the right probe. I'm tired, man. This thing's been working me over. Look at that, guys. 50 ohms. Awesome. So the ohm meter is working correctly. Well, let's check out the voltage now. Okay, let's go DC positive voltage. Let's go 5 volts. We'll feed it about 1.5 volts. Okay, so that's 1.5 volts, so we should be, what, about right in here somewhere. Yeah, let's see what she does. Boom. Very, very accurate. On my Kung bar regulated power supply, and it says 1.6263. 1.6. Man, that is right on the money. Okay, well, guess what, guys? We got her fixed. So it was honestly more than likely the blown fuse. Obviously was a huge issue, but I bet you even the bad caps I replaced, and it probably didn't have to do with the fact that why it was not functioning at all. Why it's not functioning at all is because of this silly connector here. Had a broke piece of coax on the inside of that button. And what a weird way to make a connector. And what a funky thing. You test it with a probe and it says it's good, and then when you screw it in, it's not. Man, it was just fighting me all the way. Should have stuck with my keep it simple rules. Instead here I was testing tubes and resistors and tracing circuits, and should have just went to continuity right off the start. Okay, well, let me go ahead and bundle this thing back together, clean it up, and give you a final view of it. Okay, guys, she's all back together, and I've run it through all of her paces, even calibrated her. Real easy to calibrate her. There's just 3 calibration things on the back of there that you calibrated with a known good reference source. But anyway, super happy with this guy. it'll definitely be getting some use on the old workbench here. These are good little VTVMs. If you don't know what a VTVM is, it's basically the advantage over a normal volt or ohm meter is that it runs a real high impedance, and you know, if you high impedance gives you a much more accurate measurement of voltages, especially such as like an oscillator grid or a AGC circuit network, something like that. It'll definitely give you a much more accurate reading, I guess is the best way to put it. I have, you know, the Surge Master has actually the receiver output is kind of the same thing, especially when you're adjusting audio circuits, but it's much less accurate than this guy will be. So, you know, my deviation as far as peaking will be much more accurate on this, especially with it being a high impedance circuit like it will be. Anyway, hopefully you enjoyed this. I didn't get in real detail. I kind of just showed you what I did to troubleshoot it and fix it. Of course, sold to me as working, you know. Go figure. But he obviously had to know that thing did not work. I mean, it had a blown fuse in it, and I imagine probably what started the whole thing was probably this bad probe wire here. I imagine that's probably what got it set to the side, and I got sold secondhand in the first place. But hey, we're back up and running now. Time to do some testing. Time to fix some more radios, right? Time to tune some more radios. Trying to figure out where I'm going to mount this up there on the bench, but it's definitely going to be one of my main tools for up here on the bench moving forward. Anyway, guys, hopefully you enjoyed this video. Have a great day out there. This is the Electron Man. If you haven't already subscribed to my channel, please subscribe and hit that bell so you know when the next interesting video is coming out.